Ben Cox. He comes from the United Kingdom, so this is probably the last time he can travel here. So I learned about Ben when he started doing Battleship over BGP, and I was a bit jealous because I did not come up with it. We talked a bit, and I asked him, hey, I have this idea how we can measure RPKI. And I think if we do this, this, and this, and then go through the gigabytes of data that come out of that, we can perhaps grasp a little bit how much RPKI origin validation is actually there on the internet. Other researchers have tried to do this before. I think they failed miserably in their approach. So it's up to clever people like Ben to provide us with proper high-quality data. Ben, take it away. The floor is yours.
Thank you. Okay. Hi, I'm Ben. Stuff's up there. So yeah, this is about measuring RPKI adoption using the data plane. I'll tell you what that really means in a moment. To start with, though, RPKI adoption is growing. That's awesome. In fact, it's growing even more if you're in RIPE, which is more awesome. It's also even better if you're in LATAM, although I think that's just because one ISP signed everything they have, which is awesome. But obviously, like, what is this? What's RPKI actually supposed to do? Bear with me. I know the previous presenter just explained this, but I'll try and do it with graphics. So, you have this set up. You're an ISP, you're an AS number, you have one upstream, in this case, the fictional Typhoon power, and on the other side, you have an internet exchange because you want low latency connectivity. And you have resources that you want to get to. Except sometimes there are bad people out there who want to hijack things, and so over the IX, someone announces like an evil version. And because you are probably going to prefer, or at least you may be biasing your metrics on your router to prefer internet exchanges because it's probably cheaper, then this will win, and that's not good. Because you'll be preferring the hijack. And there's currently no easy way, apart from RPKI, of validating this. So obviously, what you do, if you are the one who has been hijacked, you validate it, and now the import route, when you come in from the internet exchange, will be rejected because it's not coming from the right AS number, and we're all good. It's been defeated. Obviously, I think most of the time the actual risk is coming over internet exchanges. A lot of people are only counting for the fact that it's coming in over internet exchanges based on my conversation with other ISPs who are considering implementing RPKI validation. So let's go for another situation. So you have another transit provider. You just picked the two quite cheap ones. So you picked Typhoon Power and Gentco. And they both are, someone has successfully hijacked something and it's reached both of them. So in the world of RPKI, this should invalidate on both sides, and this should not route. Right? Except, obviously, what happens a lot of the time is people have default routes, or alternatively, the transit provider is sending you a default route, which actually there are valid cases in doing so, especially if a transit provider can't send you a full table in all times due to various issues on their end. But the problem is, if you are taking a full table, still, fixing this is hard to justify. Back in the previous talk, you talked about justifying it to managers. Roughly, the problem can be said as that bit of red invalid traffic is still a lot of traffic. If you're really big, that's a lot of traffic. So we're just going to run on a few assumptions here. The assumptions are people have default routes, because default routes are relatively common, at least as far as I've seen. And that a lot of people are pressing the signing buttons in their RAR control panels, but are not actually doing the final piece of work, and that is validating. To test this, I have gone one up from the Routinator 3000, and I have the ICMP 9000. Armed with some prefixes. Most of them are RPKI invalid. One is RPK valid as a control. And of course, we start firing into the internet. And we are collecting all of the things that come back from the wide scans into a bucket with all of the /00. We use that bucket to fill in other cannons, which send out specifically on those RPKI invalid prefixes. So we have buckets of hosts at this point, right? So if we take a look inside these buckets, let's see what means what. If one IP address is in one bucket but not the other, what does that mean? So if we only find a host in the ARIN RPKI signed bucket, well, that's great. They're actually validating and dropping because we didn't get responses from the invalid. If we find them in the ARIN correct and ARIN incorrect, then they're probably using ROA validators on defaults and have not imported a certain TAL, and I'll get to that in a bit. If they're in all of them, well, they're not validating anything. I said earlier about that particular TAL, so what do I mean by that? Not all ROAs are equal? Like, that's not how this is supposed to work. Well, turns out, yeah, ARIN, turns out, doesn't want you, that's not the right word to say, it's more, they put up a load of, they don't allow you to include it by default in your validator software because you have to sign some agreement, which is 3 very long pages of legalese. That has a bunch of very questionable clauses in, as far as I understand. So for this reason, you have to manually download it yourself, and you have to agree from it, which means, of course, that people don't, because people go for the defaults, because the defaults should always be correct in software. Obviously, that's not true in the real world, but unfortunately, a lot of people download software and assume the defaults are good. So what are the total counts? So bear in mind, these are not going to be absolute counts because these numbers were slightly denoised. So here are roughly the counts. Across the internet, there are 130 million hosts that respond on the ARIN good bucket. There are 128.2 million who respond on the write invalid bucket. And there is 128.3 million who respond on the ARIN invalid bucket. So there's about 0.1 million between the two. We also have other IP ranges to test. So we have AppNIC to test as a control, although for some reason we noted later on that AppNIC has weird routing according to other ISPs. I think some ISPs have some strange static routes involved, which put them down bad paths, because AppNIC consistently has worse packet loss in some regions, which makes no sense, because all of these IP ranges were announced from the same machine. But reasonably speaking, ARIN it sticks out quite a bit. What does it look globally across all ISPs? Well, if you take the top ISPs, I'm afraid it looks kind of grim. You probably can't read what's on there, but that's roughly, the colors are how much they drop in each RAR, and it's all bad. However, there is good. If we look at the ones who are succeeding, quite a few medium-sized ISPs are doing a really good job at dropping everything invalid. So if you are one of these, well done. If the keen eye would notice that 91% of these are Dutch. So I guess you just really like RPKI. 3% are Belgium, and there's a Moldovan, a Brit, and a German there. So if we add all of these hosts up together, we roughly get to a /15 worth of hosts that are protected, which is, it's a number. You know, it's not awful. And so, but the question is, how many are suffering from the fact that they configured things on defaults? So if we look forwards, the middle section, or so the one with red in it, basically, is the ARIN column. You'll see that a lot of people are validating all of them except ARIN. This is because they don't have the ARIN TAL, and so they have no way of actually verifying whether the ARIN things are correct or incorrect, and so they let it through as by default. So it's interesting to prove the fact that there are setups out there that exist where this decision by ARIN has actually ensured that people are not going to be validating their routes, which means that you're probably worse off trying to secure ARIN routes. Not to mean that you shouldn't try, but you shouldn't expect it to work on all ISPs because of this current restriction on the TAL. What about those who accept default routes? And so generally speaking, if something is invalid, it may just take the default route. You can actually measure this. There are some hosts on the internet where you can consistently measure the routing difference in latency. So in this case, there was a 3 millisecond difference if you just kept trying over and over, which is interesting. I can't do a reverse trace route on the other side, so I can't see which particular methods they're changing. But it's interesting to verify All of the data on these spreadsheets are available after the talk. So if you're really curious and are really good with Excel, you can probably also find other ISPs that do this. But anyway, my real point is, it doesn't work if you take a default route. If you have a default route, if you're going to do RPKI validation, you probably want to do it fully. Don't just do it on like internet exchanges, because hijacks hit transit or hit the default free zone all the time. You have to do it fully to make it work. One of the things you might be thinking as well is, what if services are doing a better job? What if things like DNS are doing a better job? And that matters for one particular reason, mainly speaking because somebody hijacked Amazon's Route 53 to go and steal some magic internet money at one point, which actually prompted Amazon to start signing things, which is really good. They haven't signed everything yet. I assume they're working on it. It's not easy to validate everything. There's technical complexity. I'm sure Amazon's a large company where things like this is not trivial to do. But to test this out, I used those IPs that I was using to ping everyone on and made them DNS servers. So if you have a DNS resolver, you can go and check if you're actually doing RPK validation correctly by the fact that if you can query these and they respond back with the IP address 1.3.3.7, then bad news, you're not validating. But that's fine, because you're in good company. 1.1 doesn't. Google doesn't. Quad 9 doesn't. In fact, even Freenom World doesn't. And actually, if you look on Ripe Atlas, no one does, apart from one probe, which was one of the probes listed in the green sheet. So if you're gonna, yeah, my point. So lessons. Sign your prefixes. If you're going to sign your prefixes, please validate them as on your router as well. This only works if people do both steps. You can't just sign your prefixes and then hope that the world becomes better because you've done it. You actually need to also validate your import because otherwise RPKI doesn't work if everybody else isn't doing it. Consider not having a default route if you're taking a full table and you can get away with it. And make sure that when you're configuring your RPKI validators that you, assuming that you want to accept Aaron's weird legal agreement, ensure that they're actually configured correctly and has the Aaron towel in it. I'd like to give some shout-outs, and that's a smaller font than I thought. Huge thank to Job, who lent his 10 gigabit server to help me smash out some packets. Nepal Research and Educational Network for the AppNIC prefix. JapanNIC /PPPXP, I'm not sure if that's an acronym I was supposed to expand or not. NTT Communications for the Aaron and Write prefixes, and Laris Cloud Services for the AfriNIC prefixes. I have questions. I can take questions, I mean. And if you actually want to see the original data, then here's some QR codes and links.
You are the first one to use QR codes. Yeah.
It's way easier to like take a photo of.
Oh well.
Jan George, hello. Well, very, very useful presentation, very useful research. Thank you for this. The only thing that actually popped in my head was you are talking about ASs and prefixes. Do you mean IPv4 prefixes, IPv6 prefixes, or all of them?
It would be very hard to do a like all IPv6 IP addresses scan. So I just stuck to IPv4.
Okay.
So all IPv4 prefixes were pinged multiple times. I didn't touch IPv6 because while there are some intelligent ways to ping all IPv6 addresses, I decided that's not really in scope.
Okay, if you find a way how to do this research on IPv6, then that would also be great. Thank you.
Any other questions? Well, I think it's quite phenomenal that the Netherlands is absolutely leading in RPKI origin validation. And we're probably the world's worst IPv6 deployer, but hey, we're making up for it with RPKI.
Oh, nice.
Ben, thank you very much.